Welcome again at Linear Audio, Wisse. It's nice to have you here again, and I have something to talk about which I think will interest the viewers and you, of course. I call it the Autoranger. Okay. It's a little development I made. It's I have it here, a little box. What does it do? Well, a lot of people in audio, hobbyists, but also professional people, but they often use a sound card and software to do measurements. But there's only one big difference between, let's say, an audio precision and a sound card based measurement system. The audio precision has internally kind of an automatic volume control, in such a way that whatever you put on the input, whether it's 1 volt for your preamp or whether it's 50 volts from your power amp, it always make sure it's about 1 volt for the internal circuits, because they work best at 1 volt. It takes anything you throw at it, whether it's 0.1 volts or 100 volts, and it makes sure that what comes out is 1 volt, which is a good level for your sound card
suitable for
and the
sound
rest
cards.
of your measurement system to work.
I see, clever.
Yeah. The power supply for this thing is what we talked about before, the silent switcher.
Okay, yeah.
So it's a small plus or minus 15 volts and plus 5 volts power supply, which runs from a USB charger or from a power bank. Yeah. So there is no connection directly to the mains, no mains transformer. And that's very important, because in test and measurement equipment, especially sensitive one, you always have hum and main stuff. And that's completely gone now. So I will just connect it to a power source and then fire it up.
Yeah, sure. Yeah.
I'll take the lid off so you can see inside. Yeah. So you see here in the back, that's the power supply, the silent switcher. And then here, this main board does all the switching. Don't mind the soldering. This is my prototype, so my soldering is not perfect.
We will not hold it against you.
Hopefully not. So you see here some relays and there are some precision resistors, and the whole thing is controlled by a little microprocessor that's here, a PIC microprocessor, and some buttons and a display to work with the user, of course.
So it measures the voltage?
So the voltage comes in here, and there are 2 inputs. There is a single-ended input and a balanced input. And this voltage is checked by the controller, and if it's above 1 volt, then it's attenuated step by step by step by step until it goes to 1 volt. If it's below 1 volt, the gain is increased until it gets to about 1 volt.
Okay.
Yeah.
Can you tell a bit more about the controls in the front?
Yes. So these are push buttons you select to get the single-ended or the balanced input. And then here you have on the output side, you have a single-ended and a balanced output. They are both all the same all the time present, so you don't have to select them. There's also a little hold button, which is important, because if you want to measure, let's say, distortion as a function of voltage level, you want to vary the voltage level from 1 to 10 and see what the distortion does. But in that case, you don't want it to switch. Yeah. You want it to, so what you do, you set up for 10 volts and then you press hold, and it will stop switching, and then you can vary your voltage level and do your measurements, distortion or whatever. And there are 2 little LEDs that says whether it's over range or under range, because if you put in too many volts, like 150 volts, that's too much. It can handle 110 volts, and then you get a red LED which says, hey, it's too much. Yeah. Or when it's not enough, you get a green LED. Yeah. But I think if we I have a little power bank here which I charge from a USB charger. From a well-known magazine. So this battery is now powering the Autoranger. I put it in here and I switch it to on. It goes through some self-test, and then you see, well, there is no input voltage, just a few millivolts noise because it's open, and you see that the gain is plus 16 dBs. Because it tries to get it up to 1 volt, but it doesn't get there because there's no signal, and that's also why the under range is on. Now if you press hold, you can see there hold, and you can do whatever you want and it will stay on the 16 dB gain. So there are several indications. You see the output voltage, V0, that's what goes to your sound card. That's the input voltage, which is what you get in here, but which at the moment is almost zero. And then you see the difference between input and output, the gain, or we will see later the attenuation.
Yeah.
So
okay.
what I propose is we hook it up to my
sure.
distortion tester, and you can see how clean it is and
yes.
how.
Let's do some measurements. Let's put it to the test.
Okay. Yes. So I put the signal in. I put the signal out.
What test equipment are you showing us there?
This is a D-scope from Prism Sound in the UK. It's let's say almost high-end test equipment. It's not in the same level as an Audio Precision, but it's very close. Okay. It's much cheaper. And I will start up the program for it. So the nice thing about this equipment is that you can see both the signal, the time domain.
Hold on, let me get a bit closer.
Which is the signal.
The signal is...
It's the signal that comes out of the Autoranger. It's the green sinus.
Yeah.
I put in 1 kilohertz and outcomes of course of 1 kilohertz, only different level. And the red trace is the spectrum. So there you can see, let's say the distortion or the spectrum.
Okay.
Now, here you see it's 1 volt, 1 kilohertz, 1000 hertz. And if I hit the trigger, then it starts to measure. So 8 samples. That's it. And you can, so here is 1 kilohertz, so this little red line is your input signal. Yeah. 2 kilohertz second harmonic, which is about minus 120 dB. 3 kilohertz the third harmonic is also at just about minus 120, the fourth also. So it's almost minus 120, not close, not all, because there is here, it's not exactly at zero, so it's about minus 115. Yeah. Now this is actually the limit of the test equipment. If I let the test equipment measure itself, I see the same spectrum. I set the test equipment to output 1 volt, and you see it's within 0.3%. It's indicating 1 volt. 1 volt in, 1 volt out, so there's no need to attenuate or to get any gain. 0 dB, 1 volt out, 1 volt in.
Can you tell a bit more about the frequency response of the Autoranger?
Yeah. That's an important parameter for the unit, because if you want to use it with a sound card and a test and measurement system, you want the Autoranger not to be the limit. I have set up a measurement here with the Autoranger on a piece of equipment called the Bode 100, which is a piece of equipment that you can use to measure frequency responses. And the output of the generator goes to the input of the Autoranger. You can see that it's set up for single-handed input and on hold, so that it doesn't switch while the measurement is going on. And the output of the Autoranger goes to the Bode 100. If you look at the screen, this is a typical setup where you see here the dBs, the magnitude of the signal, and here the frequency. And when I start it, it will sweep and it will measure the frequency response.
Give it a start.
I will do that now. It measures from 5 Hz to 200 kilohertz. You see the little red triangle. I'll give it a few seconds to finalize. It should be finished in 5 or 10 seconds. So let me explain a few things. Here's 1 kilohertz, and here at the end is 200 kilohertz. And there are 2 cursors, the green one and the red one, and here you see the difference between the cursors, which is 4.2 millidB. So between 1 kilohertz and 200 kilohertz, it's almost ruler flat. Yeah. On the lower side, you see it starts to fall off, and it's about minus 3 dB at 5 Hz. There is another thing that I should tell. Maybe I can explain it right now. If you want to use it with a certain attenuation, you might want to have some manual input on the attenuation. If you set it to hold, I explained it. You set it to hold, you can change the voltage, and it stays on 0 dB. But then if you press this button, it goes to minus 20 dB, 1 volt input, 0.1 volt output, more or less, within a few percent. So you might use that manually if you would want that. And actually if you push this one, it goes to minus 40 dB. So if I release hold, it goes back and we're back at the 0 dB 1 volt.
Okay.
So what I now want to show you is that I increase the input voltage up to 100 volt, and you will see that it goes a little bit up, down, but it stays around 1 volt.
Okay.
Because that's the main function. It's auto ranging.
Yeah.
Okay.
Yeah.
So
Good.
what I do, I take a signal from my test equipment and put it through this amplifier, and this amplifier can output more than a 100 volt signal. So I put that 100 volt, maximum 100 volt signal into the Autoranger, and then we can see here on the display what the input is and the output, and you can see that when I turn it up to 100 volt, the output will always stay around 1 volt, but you will see that attenuation here, of course, goes up, because at the end, even 40 dB of attenuation to make from 100 volt to make 1 volt.
And what is the frequency of the signal?
This is a 1 kilohertz,
1 kilohertz signal.
test
Okay,
signal.
good. Yeah. And we're going to
increase it. So right now the voltage is 0. Now I'm going to increase it a little bit, and you will see I now send 6 volt to the Autoranger, and the output is 0.967. So it's almost 1 volt.
Okay.
It will never be exactly 1 volt, because to switch you have to go up, and then it switches down, and then it switches up again. So it's always around 1 volt, not exactly 1 volt.
Sure. Yeah.
But you see the attenuation is 16 dB, because the 6 volt has to attenuate it to be around 1 volt. Now if I continue to turn it up, like 16 volts, attenuation is minus 24 dB, output 1.055 volts. And I continue, I turn it up to 75, I turn it up to 100 volt 0.7, and the output is 1.007. So it's exactly 40 dB difference, and that's attenuation that is shown there. Yeah. I can also show you now the hold. If I say hold, it stays at minus 40. That means if I turn it down, you see the input voltage going down, and the output voltage going down, because it doesn't switch.
Yeah.
So both go down. But if I release hold, it says, I have to go from minus 40 to minus 32, because then I am about 1 volt output with 40 volts input.
So very clever piece of equipment, very useful for a lot of people working with audio.
If you have this and you have a sound card and you have some of the things like an ARTA or RMAA or True RTA, which is the software that can use a sound card, you have a complete measurement system, which is almost as good as a $10,000 measurement system.
Okay, good. Well, okay. Yeah. You will bring this on the market.
Actually, what I would like to do, like I did with the silent switcher, is to do a Kickstarter project, or a group buy on one of the forums.
Yeah, so everyone has to stay tuned to see what comes out.
Yes, look at linearaudio.nl, because I will have some updates.
Linearaudio.nl,
and look at this movie, of course.
Okay, good. Yeah. Okay, thanks very much so far.